A humanoid robot just ran 100 meters faster than Usain Bolt. At the World Humanoid Robot Games in Beijing, a Chinese robot completed the sprint in 9.39 seconds, beating Bolt's 9.58-second world record. Another robot cleared 2.88 meters in a standing high jump. A robot using the same model as the 100-meter champion ran 400 meters in 39.7 seconds, faster than the human world record. These machines can now sprint, jump, fight, play soccer, lift weights, and race around a stadium at speeds that would have looked absurd only a few years ago. But then comes a much harder test. Plug in a cable. That sounds almost ridiculous. A machine that can outrun the fastest human in history should surely be able to connect two pieces of plastic. But this contradiction reveals something fundamental about humanoid robots. Extreme physical performance is becoming surprisingly achievable. Reliable intelligence in an imperfect physical world is much harder. That is what makes China's latest robot games more interesting than the headlines about sprint records. More than 2,000 humanoid robots are taking part in the 5-day event at Beijing's National Speed Skating Oval. There are 51 categories and more than 1,000 competitions, ranging from running, table tennis, and soccer to factory assembly, restaurant service, warehouse work, emergency response, and electric vehicle charging. Reuters says 21 events are specifically designed around real-world scenarios, and more than 40% require robots to operate fully autonomously. That changes the purpose of the competition. A sprint mainly tests motors, mechanical design, balance, battery output, thermal management, and control. The environment is simple. The track is flat. The direction is obvious. There is almost nothing to understand. And even there, the robots still have problems. After crossing the finish line, some of the fastest machines could not stop smoothly. Organizers placed thick mats several meters beyond the line because the robots sometimes crashed directly into them. Reuters described braking as one of the obvious weaknesses exposed by the competition. That makes the scene almost perfect. The robot can beat Usain Bolt, but it needs a padded wall to stop. Now compare that with connecting a cable. The robot has to find the connector. It must estimate its orientation. It must move its arm into approximately the correct position. The hand must rotate precisely. The connector must be aligned with a socket that may be only a few millimeters larger. The machine must apply enough force to insert it, but not so much that it damages the connector. If the cable moves while being touched, the robot must notice that change and correct its plan. And if the first attempt fails, it must understand why. This is where physical AI becomes difficult. A factory robot has been capable of extreme precision for decades, but traditionally the environment is engineered around the robot. The object arrives at a known location. The machine repeats the same motion. Fixtures hold components in place. Cameras and sensors operate under controlled conditions. Humanoid robots are supposed to do the opposite. They are being designed to enter environments originally built for humans. Doors are different sizes. Boxes move. Chairs are left in the wrong place. Cables bend. Objects slip. Lighting changes. A person suddenly walks in front of the robot. A bottle is slightly farther away than it was during training. Reuters describes these tiny imperfections as potentially more revealing than the spectacular sports competitions. They force the robot to recognize objects, position its entire body correctly, control force, and recover from mistakes without human intervention. And recovery may be the most important part. Humans fail constantly during physical tasks, but we correct mistakes so quickly that we barely notice. Reach slightly too far for a cup and your fingers adjust. Start inserting a USB connector at the wrong angle and your hand immediately feels resistance. Step on an uneven surface and your body changes balance before you consciously think about it. Robots must learn versions of these abilities through sensors, models, and control systems. That requires something very different from the intelligence inside a chatbot. A language model operates inside a digital environment. It receives tokens and generates tokens. Even when an AI agent controls software, the world is relatively structured. Buttons have coordinates. APIs return defined responses. Files have known formats. Physical reality does not have an API. A robot has to infer what is happening continuously from cameras, depth sensors, force sensors, joint positions, and other signals. Then it has to predict what will happen if it acts. This is why world models and embodied AI have become such important ideas in robotics. Instead of programming every movement individually, researchers want robots to build an internal representation of the world. The machine should understand that pushing a box causes it to move, that a cup can fall, that a cable bends, that another person may block its path, and that the same instruction can require completely different movements depending on the environment. Recent progress suggests that the hardware side is advancing rapidly. Reuters reported that China's robotics competitions looked dramatically different only 1 year ago. In 2025, many humanoid robots competing in Beijing's half-marathon collapsed, crashed into barriers, or required engineers to run beside them. Only a fraction completed the event. By 2026, more than 100 teams entered and 47 finished. One humanoid from smartphone maker Honor reportedly completed a half-marathon autonomously in 50 minutes and 26 seconds, nearly 7 minutes faster than the human world record set the previous month. That is an extraordinary improvement in a very short period. Reuters attributes part of the progress to China's increasingly competitive robotics supply chain, falling component costs, and government support. Motors, reducers, batteries, sensors, and controllers are becoming cheaper and more capable. China also has a huge manufacturing ecosystem capable of turning prototypes into physical products quickly. This may become one of China's largest advantages in humanoid robotics. The country already produces the majority of the world's humanoid robots, according to AP. At the same time, the World Robot Conference held alongside the games displayed around 3,000 robotic products. But producing robots is different from producing useful robot labor. That is the central question behind the entire industry. Can these machines leave demonstrations and perform economically valuable work? Lumos Robotics CEO Yu Chao told Reuters that running and jumping alone does not improve efficiency. The real value appears when the robot can solve problems in the environment where the customer actually needs it. This is why the less glamorous events at the games may matter more. An electric vehicle charging task tests whether a robot can locate a charging port, manipulate a relatively heavy cable and connect it precisely. Restaurant work tests perception, navigation, and manipulation around humans. Warehouse tasks test package handling, object recognition, and repeated movement over long periods. Industrial assembly demands accuracy measured in millimeters. And hand dexterity competitions go even further. Robots are being tested on tightening screws, opening bottles, and even picking up small beads with tweezers. Reuters notes that robotic hands remain one of the most difficult engineering problems in humanoid design. A human hand has an extraordinary combination of strength, sensitivity, flexibility, and control. We can lift a heavy shopping bag, then immediately pick up a coin. We can feel an object slipping before we see it. Replicating that combination in a machine is extraordinarily difficult. And then the AI controlling the hand must understand what it is touching. This is why the next humanoid breakthrough may not look dramatic on video. It might be a robot that spends 8 hours in a warehouse and makes almost no mistakes. A robot that plugs in 500 cables and succeeds 499 times. A robot that encounters an unfamiliar package, tries one grip, notices that it is unstable, and automatically chooses another. That would be less exciting than watching a robot beat a human sprint record, but economically it would be far more important. The games also reveal how quickly the competition is becoming geopolitical. Teams from 16 countries are participating, including Germany, Japan, and the United States. At the same time, the United States has increased scrutiny of Chinese robotics companies. AP reports that the FCC recently banned imports of new foreign-made humanoid robots on national security grounds in a move aimed largely at China, while Unitree was added to a Pentagon list of companies considered to have links to the Chinese military. China has rejected those accusations. That creates a familiar pattern. The semiconductor race began as a competition between companies. It increasingly became a competition between national technology ecosystems. Humanoid robotics may be heading in the same direction. China has manufacturing scale and a dense hardware supply chain. American companies remain strong in frontier AI models, advanced computing, and software. The company or country that eventually combines both worlds may gain an enormous advantage, because the ultimate humanoid robot needs both. It needs a body cheap enough to manufacture by the millions, and a brain intelligent enough to operate that body without constant human supervision. The sprint record tells us that the body is improving very quickly. The cable tells us how far the brain still has to go. And that may be the most important lesson from Beijing. The future of humanoid robots will probably not be decided by who builds the machine that jumps highest, runs fastest, or performs the most impressive backflip. It will be decided by the machine that can walk into an ordinary workplace, encounter something slightly different from what it saw yesterday, understand the problem and continue working. A robot that can beat Usain Bolt makes a great demonstration. A robot that can reliably plug in the cable could change the economy.